what I am going to do is just present my screen real fast, just to show you just a little review of some impulse and what really impulse means. Okay, what is impulse? All right, so we ended on this slide, right? So we said impulse was the change in momentum, right? So impulse is equal to the force times time, which is equal to the change in momentum, right? Now, the reason we consider impulse is these are some applications. Okay, so most problem, you don't need to write this down. It says most problems involving impulse will involve a force being in contact with an object for a very short time. So an example is boxing. So people wear gloves because it increases the amount of time uh, for a punch, right? So that they don't get us hurt. Whereas if force was increased, okay, well, that would hurt a lot more. All right. Um, car airbags, hitting a baseball. We're going to look at various, well, mainly those three examples. Um, so impulse involves time, right? For a longer period of time, making, yeah. Okay. So if we look at this, I think that's a tennis ball. If you look at the tennis ball, it's falling, it's falling, it's falling. If you look here, it's like half the size. But that means it's just being compressed. So we have the force. The force is the greatest, and that's the impulse curve. Okay? That's what an impulse curve looks like. Now I have a few videos that I want to show you guys. Have you guys ever heard of parkour before? It's pretty awesome what they do. Uh, they basically jump off ledges and do crazy stunts. But what I want you guys to look at is how do they land? How do they land each time? Some of them cut it off. That guy's like Superman right there. Well, as you can see, they always land with bending their legs and rolling. So that compression, when they bend their knees like that, that compression increases the amount of time, which decreases the amount of force on their legs. And that's what this impulse is. Whoa, that was kind of scary. That's what impulse is. Another example is a baseball, hitting a baseball. They did this experiment where they had a bat. Well, I went too far. Where they hooked a bat up to a machine and tossed baseballs at it. And I have the volume off, but what happens is they did it in slow-mo, and what you can see is the ball compressing. So see the compression on the ball. So that compression actually makes the baseball have less of a force and go less of a distance in result. All right. Look at that. That is crazy how much the baseball gets compressed. And that's what impulse is. Okay. Just a few videos to give you guys some some visuals. Already saw that. So if we asked ourselves, airbags are used in cars because why? Why are airbags used in cars? Is it to increase the force with which a passenger hits the dashboard? Well, hopefully we don't say that one. Increase the duration time of a passenger's impact or decrease the duration of a time. Well, if we decreased the time, that would actually increase the force. So we don't want that. So hopefully you said B, because F times T, right? If T is increased, the force is decreased. And that's why we use airbags. That's why it decreases the amount of force, which is fascinating stuff. And I'm going to do one mathematical example so you guys know how to calculate it for today's experiment. So if you see this example, Charlie's playing t-ball. Awesome. He's about to crush a home run over that fence. I don't think any kid out there is paying attention to this kid hitting the ball. That's just silly. All right, so Charlie is playing t-ball. All right, so what I'm going to do is I'm going to pull this up, get a piece of paper. He swings at a 144 kilogram ball that is at rest and hits with a force of 182 newtons, which is in contact with the ball for 0.009 seconds. How fast is the ball traveling after it is hit? Well, our impulse equation is force. Let me zoom in a little bit. Our impulse equation is force times time is equal to the change in momentum, right? So my force is 182. My time is 0.009. That is equal to my change in momentum. Well, my change in momentum, well, that's going to be my mass times velocity final minus my mass times velocity initial. Okay, so let me rewrite this. 182 times 0.009 is equal to my mass. My mass in this problem is 0.144 times my velocity final. I don't know what that is, so I'm solving for my velocity final, minus my mass, which is 0.144, times my velocity initial. Well, it's sitting on a t. So while it's sitting on a t, what's my velocity initial? Well, that's just going to be a big 0. So what this ends up doing, so you have 182 times 0.009. So I got 1.638 is equal to 0.144 times my velocity final, because all of that's 0. So divide that over. I got 11.4 meters per second. And that's how you utilize the impulse equation. Force times time is equal to the change in momentum. Okay. Now we're going to look at other problems probably tomorrow. But for today, what you guys are going to be doing is I posted an impulse lab on Google Classroom. All right. Now, mainly you're going to be doing this on your own. However, if you would like to collaborate with somebody or ask them questions, that is absolutely fine. Okay. Make sure you read the directions. All right. So each person must make a blowgun out of paper. Then you will shoot out the blowgun horizontally. You will cut the blowgun into different lengths to see the distance the dart travels. For each size of the blowgun, shoot the dart 5 times and record the data for the 2 that went the farthest. All right. So this is an interesting experiment. All right. So you're going to create a hypothesis. And then you're going to fill in this chart down here. So the length of the blowgun, record it in centimeters. Okay. You're going to have, remember, the 2 farthest. So there's 2, 2, and 2. The mass of the dart. Can somebody actually do me a favor and let's see, Jake, can you do me a favor? Behind you, the cabinet's all the way to the left, the top all the way to the left. Open up both of those. Is there a scale in there?
You said there was one in there.
Awesome. Okay, so get that. All right, that should be in grams, or what is it preset on? You should be able to get it in grams. All right, it might be preset on ounces, but there's a button that you can change it to. So get it in grams. However, when you're recording it, the mass has to be in kilograms. Okay, so make sure you convert that. The height of the dart. All right, so the height of the dart. So it's going to be from the ground to where you're shooting off your dart. Okay, horizontal distance, that's going to be easy. Now the velocity final. This is a little interesting. Okay, velocity final, you're going to have to use some projectile information here. So you might need to go back to your projectile notes. Now, if you still have questions, I'll help you out. But try to get the velocity final out of this. All right. And then you should be able to calculate some impulse. All right. For this experiment, let's see. Oh, I didn't put the materials. All right. So what you're going to do is you're going to roll up a piece of paper. Now, I have paper. Let's see. I was looking for Josh. Where's Josh at? There he is. Josh, I have paper behind you to your left up top. Not that. Yep. Nope. The other one to your right. Yeah, there should be paper in there. Okay. And there should be some scissors in there. You can grab the colored paper. Was he able to find it? It should be in all the way to the right.
We have yet to find it.
Huh. There should be colored paper all the way to the right there. In those cabinets. Oh, you got it? Beautiful. So you guys are going to be rolling up a piece of paper, all right? And then you guys are going to tape it, all right? There should be tape on my front table. Now, each person is going to grab 5 darts. There should be darts on my desk, all right? There should be Nerf darts. Have you guys located those? Beautiful, all right? Works really well, actually. I was able to get, man, what was my number? I got my numbers written down somewhere. I was able to get, I think 8 meters, 9 meters, 10 meters. All right, so you're gonna tape it. All right, you're gonna load in the dart, blow it. All right, record, do it 5 times, record your 2 longest ones. Then you're gonna cut your blow dart. So instead of my full length, I'm gonna cut it to that length. Okay, and then I'm gonna do 5 more, and I'm gonna cut it to that length. All right, make sure you record as you go. All right, does that kind of make sense what we're doing? All right. And then at the end, there's just some problems. All right. Well, I guess it will tell you. All right. Just some problems at the end of how could you get it farther? A little calculation example. All right. So like I said, measure the mass of the dart in kilograms, height, distance in the x direction, right? And then calculate the final velocity. All right. Now, I'll give you a hint. All right. You're going to look at the final velocity in the x direction because y is going to be 0, because what you guys are going to be doing is you're shooting it horizontally. Just a little hint. Okay. If you guys have any questions on today's experiment, let me know. I will be on the Google Meet the entire time. So if you guys ever want to pop back in, I'll be here. For my virtual people, well, if you guys don't have any questions, you guys are good to go. People in the classroom, you guys are good to go. For my virtual students, I got my data. So I did this experiment at my house before dropping off the darts. I got my data so I can share what I got with you guys. And I'll post that on Google Classroom here in a minute. Sound good?
Yep.
Sweet. Okay.